Hello students, today we are going to perform the polarity test, open circuit test and short circuit test on a single phase transformer. In this experiment, part A is polarity test on a single phase transformer. Objective of this test is to find the polarities of windings for a given single phase transformer. This is our given single phase transformer. Rated primary voltage is 115 volts, secondary voltage is 230 volts and kVA rating is 1 kVA rating. Here between these two terminals we have primary winding, between these two terminals we have secondary winding, and we are using the iron core transformer. This is the single phase variac. By using this single phase variac, we are giving the supply to the transformer primary winding. Input voltage of this single phase variac is 230 volts 50 Hz AC supply. Output of single phase variac we can vary from 0 to 270 volts. Here across primary winding we have connected one voltmeter. Across secondary winding we have connected voltmeter 2. And P2 S2 we have shorted, these two terminals we have shorted, and across these two terminals P1 and S1 voltmeter 3 we have connected. If the supply voltage is given to the transformer primary winding through single phase variac, V1, V2, V3 values we can see. If V3 voltmeter gives the sum of V1 and V2 voltmeter readings, then it indicates that P1 and S2 terminals, this is P1 and this is S2 terminal, these two will be dotted. If V3 measures the difference of this V1 and V2 voltmeter readings, then P1 and S1 will be the dotted polarity. We have connected this circuit as per the given circuit diagram. This is an auto transformer. Auto transformer input voltage is fixed 230 volts 50 Hz AC supply, and output we can vary by adjusting this knob. We can adjust 0 to 270 volts. This is our transformer, and here we can write this one is the P1 and this is P2 terminal, and here it is S1 and here it is S2 terminal. In between these two we have a primary winding, in between these two terminals we have secondary winding, and primary winding is connected across the auto transformer output, and we have connected one voltmeter across this primary winding of transformer, or we can connect output of auto transformer, because this output and transformer primary both are connected in parallel. And this P2 and S2 we have shorted here, and here in between S1 and S2 we have connected the voltmeter 2, and in between P1 and S1 we have connected the voltmeter 3. Now I am going to switch on the supply to single phase auto transformer, and then by adjusting the single phase auto transformer output, I am going to apply the rated primary voltage, that is 115 volts. Now we have applied the 115 volts across the primary winding of transformer by varying the auto transformer output. Now V1 reads the 114.6 volts, it is near to 115 volts, and V2 it is giving 229.1 volt, and V3 here it is giving 342 volts. If we take the sum of 114.4 and 229.3, it will be close to 343 volt. So here V3 is reading sum of V1 and V2 voltmeter readings. Therefore, polarities should be P1 and S2 terminals. So here P1 is the dot polarity and S2 is the dot polarity here. So we have marked the dot polarity for primary winding and we have marked the dot polarity for secondary winding. Polarity test is the one of the necessary test for connecting the two or more transformers in parallel. We have marked the polarities of primary and secondary windings for the given transformer. Now I am going to reduce the auto transformer output voltage to 0 and then I am going to switch off the supply.